Netflix processes 2 billion metadata events daily, and a single bad transformation could crash the entire platform.
Wait, are you saying one corrupted movie title could take down Netflix? So we're covering how the Data Canary works, what it catches that code tests miss, and how to build one.
By minute 4, you'll know exactly how to stop bad data before it hits production. Let's get into it.
Welcome to the Platform Engineering Playbook Daily Podcast. Today's news and a deep dive to help you stay ahead in platform engineering.
Today we're diving into the Data Canary, how Netflix validates catalog metadata.
Stick around to the end for today's headlines. Let's dive right in.
So let's talk about trust. As platform engineers, we spend an incredible amount of time building trust in our code. We have CI/CD pipelines, unit tests, integration tests, and sophisticated canary deployments, all to ensure the code we ship is safe. But what about the data that flows through those systems? We trust it implicitly, and that's a huge, terrifying blind spot.
It really is. We treat data like a given, like it's this immutable truth that just arrives. But it's not. It's the output of another system, which is the output of another system, and on and on. And as Netflix discovered, a failure in that chain can be just as catastrophic as a bug in the code, if not more so.
Exactly. And for a company like Netflix, the stakes couldn't be higher. We're not talking about some internal dashboard. We're talking about their catalog metadata. This is the central nervous system of the entire user experience. It's the data that answers the questions, does this title exist? Is it available in your country, in your language? Can you legally play it right now? When that data is corrupted, streaming breaks. Not for a few users, for millions, instantly.
And the incident that sparked this whole Data Canary initiative is a classic platform horror story. It had all the worst ingredients. First, the impact was massive. Playback failures, catalog services falling over. Second, the cause was completely non-obvious. The engineers on call did what we all do. They checked the deployment dashboards. Nothing. They checked the config change logs. Nothing. No code had been pushed. No flags had been flipped.
The system, from a code perspective, was in a perfect known good state, yet it was on fire. After a ton of frantic triage, they found it. A manual action taken to mitigate a completely separate previous incident had inadvertently corrupted a data feed. It basically rendered it empty for a subset of titles.
That's the nightmare scenario, a ghost in the machine, a side effect from a past change. So for a certain group of movies and shows, the metadata just vanished. And the downstream services that rely on that data, like the one that generates the playback manifest, just started failing because they were receiving an empty payload where they expected rich data.
Precisely. And here's the kicker, the part that should make every platform leader sit up and pay attention. Their sophisticated, expensive, battle-tested code canary analysis system saw nothing. It was green across the board because its job is to validate code, and the code was fine. The data was the deployment. The data was the bug.
It exposes a fundamental flaw in how many of us think about deployments. We see a deployment as a change to an artifact in a repository, a new container image, a new Lambda function version. But a new snapshot of a data set being published into a production pipeline is also a deployment. It's a change in state that can absolutely break things.
That was the big realization for Netflix. They needed to treat data deployments with the exact same rigor as code deployments. But that's way easier said than done. Their catalog metadata pipeline is this high-velocity beast. It's constantly ingesting data from dozens of upstream sources, transforming it, and publishing a new, complete state of the catalog that then gets fanned out across their entire global infrastructure.
So the challenge becomes, how do you validate something that's moving that fast? With code, you have a discrete event, a Git push that kicks off a pipeline. You can canary that single change for an hour. But if the data is changing every 10 or 15 minutes, your validation window is tiny.
Exactly. And that was just the first of several massive problems. So the problem is clear. You need to validate data, not just code. But how? Coming up, we'll break down why their existing Canary tools were completely useless for this task and the 3 massive hurdles they had to overcome to even get started.
The trade-off is obviously the complexity. This isn't a weekend project. This requires incredibly tight integration between your data build process, your traffic routing layer, your client-side instrumentation, and a near real-time metrics and analysis pipeline. It's a significant engineering investment.
It is, but the principles behind it are scalable. Okay, so they built this incredible system that uses a tiny slice of production traffic to validate data in minutes. But how can a platform team at a smaller company even begin to think about this? Stick around, because in our final act, we're breaking this down into a practical playbook you can actually use. So, the big lesson from Netflix's Data Canary is a fundamental shift in mindset. We have to start treating data pipelines as deployment pipelines. A new data snapshot hitting production is a deployment, period. It deserves the same level of scrutiny and automated validation as a new service binary.
But most of us don't have Netflix's resources or their scale. Building a full-blown data canary orchestrator is a multi-year effort. So where do you start? What's the 80-20 version of this?
I think it breaks down into a playbook. Step 1, identify your critical data paths. Not all data is created equal. You need to sit down with product and business leaders and ask, what data, if it were suddenly empty, null, or malformed, would cause an immediate P0 level business catastrophe? For Netflix, it's catalog metadata. For an e-commerce site, it's product pricing and inventory. For a fintech app, it's account balances. Map these out.
And be specific. It's not just user data. It's the user profile object that gatekeeps login. You need to find the data that acts as a critical dependency for your most important user journeys. Once you have that list, you can prioritize.
Step 2, define your golden metric for each of those paths. This is crucial. The metric cannot be CPU utilization or API latency. It has to be a business-level KPI that represents user success. For Netflix, it's successful stream playback. For an e-commerce site, it might be the add-to-cart success rate, or even better, the order completion rate. This metric becomes your ground truth. If it goes down, you have a problem, regardless of what your system dashboards say.
And that metric has to be measurable in near real time. If your order completion rate is something you only calculate in a data warehouse job that runs overnight, it's useless for this purpose. You need client-side or server-side instrumentation that gives you a minute-by-minute pulse on that KPI.
Exactly. Now for step 3, which is where you can really start small, the manual canary or readiness probe. Don't try to automate traffic steering on day 1. Instead, change your process. Before you publish a new critical dataset to production, publish it to a staging environment. Then run a new kind of test suite against it. Not unit tests, but journey tests.
Right. You can have a script that uses a test account to perform the most critical user journey. For our e-commerce example, the script would log in, search for a product using the new data, verify the price is correct, add it to the cart, initiate checkout, and if any of those steps fail against the new data snapshot, you fail the data deployment and block it from going to production. It's a programmatic readiness probe.
It's a fantastic starting point. It's not as high fidelity as real user traffic, but it will catch a huge class of problems that schema validation alone would miss. From there, you can move up the maturity ladder. Step 4 is looking for proxies. If you can't use real production traffic, what's the next best thing? Replaying sanitized production logs against your staging environment with the new data is a great step. High-fidelity shadow traffic is even better. It's a spectrum of confidence.
I think another key takeaway is the idea of data contracts. A lot of these issues happen because the producing team and the consuming team have a misunderstanding about the data's shape, content, or semantics. Formalizing these expectations with something like a data contract, schemas, value ranges, guarantees about nullability, can push a lot of this validation further upstream. It's about preventing the bad data from ever being generated in the first place.
It is, and it feels like this is the next frontier for platform engineering and reliability. We had the first wave, which was about making individual services resilient. Think Chaos Monkey. Then we had the second wave, focused on making deployments safe. Think Spinnaker and progressive delivery. This feels like the third wave, data resilience, ensuring the information flowing through our resilient, safely deployed systems is actually correct and trustworthy.
It changes the fundamental question for an on-call engineer. For years, the question has been, is the service up? Now, the more important question is becoming, is the service correct? A service that's up but serving bad data can be infinitely more damaging than a service that's down.
And that's the real playbook here. It's not just about building a tool, it's about evolving your definition of production readiness. It's no longer enough for your code to be ready, your data has to be ready too. And you need the systems in place to prove it every single time. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating new development for anyone managing Spring Boot deployments in Kubernetes. Alexander Obregon just published a deep dive on Medium about container readiness checks that could save teams from those dreaded, my app is up but not really ready scenarios.
Oh, readiness probes. I've seen so many teams confuse these with liveness probes. What's the key takeaway here?
He really emphasizes how readiness probes prevent traffic from hitting your pods before they're actually ready to handle requests. It's especially critical for Spring Boot apps that might need time to initialize database connections or warm up caches.
Speaking of enterprise-scale challenges, LinkedIn just completely redesigned their static analysis pipeline. According to InfoQ, they're leveraging GitHub Actions, CodeQL, and SemGrep to handle code scanning across their massive multi-repository environment.
The scale is mind-blowing. They needed to address performance bottlenecks while maintaining consistent security scanning across thousands of repos. Their solution provides enforceable policies without slowing down development.
That's exactly the kind of platform engineering challenge that requires sophisticated GitOps practices, which brings us to some timely news. PlatformEngineering.org just announced a new course specifically on GitOps for platform engineers.
This isn't your basic here's how to use Flux tutorial. They're tackling enterprise-scale deployments with all the complexity that entails. Multi-tenancy, policy enforcement, progressive delivery patterns.
And speaking of enterprise scale, AWS just reported their Q4 2025 numbers. TechCrunch reports revenue is up 24% year over year, driven heavily by AI workloads.
Though, interestingly, Amazon shares actually fell despite the strong growth. Investors are worried about the massive capital expenditures required to keep up with AI infrastructure demands.
Makes sense. All that AI infrastructure needs observability, too. Datadog just integrated Google's Agent Development Kit into their LLM observability platform, according to InfoQ.
This is huge for teams building AI agents. You get automatic instrumentation and deeper visibility into agent behavior without having to build custom monitoring solutions.
Now let's talk releases. External Secrets just dropped version 2.0.0, and heads up, this is a breaking change release.
They've removed the Alibaba and Device 42 providers, citing lack of maintenance. But on the positive side, the Helm chart now supports host aliases, which is great for custom DNS requirements and air-gapped environments.
If you're using either of those removed providers, you'll need to plan your migration strategy before upgrading. The good news is the core functionality is more stable than ever.
And Pulumi 3.219.0 just landed with some nice quality of life improvements. You can now set required Pulumi versions directly in your pulumi.yaml file, and they've added support for using private packages as local dependencies in components.
The Parallel Analyzer calls feature should speed up deployments significantly. Plus, that new Pulumi policy install command makes it much easier to manage policy packs across teams.
That wraps up today's news. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
And check out platformengineeringplaybook.com for more resources and guides. Until next time.